Transformation of quadratic equation. A quadratic function is a polynomial where the highest power of the variable is 2. The standard form for expressing the quadratic function is ax squared plus bx plus c equals to 0, where a, b, and c are all real numbers, and a cannot be 0. The graph of a quadratic function is called a parabola. And the basic parabola or parent function is f of x equals to x squared. When we talk about the transformation of a quadratic function, we're talking about taking the basic parabola given as y equals x squared and modifying it based on another quadratic equation. The standard equation is often written in another form, called the vertex form, as this, where h and k are the vertex coordinate, and a is the leading coefficient. The vertex is the highest or lowest point of a parabola. There are various types of transformation, but here are some basic types of transformation. Vertical translation. You can represent a vertical translation or shift the graph of the function by adding or subtracting a constant, which is k, such that the function of x is given as x squared plus k. If k is greater than 0, the graph moves upward the k units. Whereas if k is less than 0, the graph moves downward the k units. Suppose we have the function as x squared. Adding a constant, let's say 3, to the function results in the function being x squared plus 3, which shifts the parabola vertically upwards by 3 units. Similarly, subtracting a constant, let's say 2, from the function shifts the parabola vertically downward by 2 units. Horizontal translation. You can represent a horizontal translation or shift the graph of the function of x given as x squared by adding or subtracting a constant h to the variable x inside the function, such that the function of x is given as x minus h all squared. If h is greater than 0, the graph shifts toward the right h units. And if h is less than 0, the graph shifts to the left h units. For example, the function of x given as x minus 3 squared will shift the graph of x squared 3 units to the right, while the function of x given as x plus 2 squared, which can also be written as x minus 2 squared, will shift the graph of x, which is x squared, 2 units to the left. Vertical stretch and compression. You can represent a vertical stretch or compression by narrowing or widening of the graph of the function of x given as x squared by multiplying x squared by a constant a, such that the result will be x squared. If the magnitude of a is greater than 1, then the graph will stretch vertically, thus appearing narrower than the parent function. If the magnitude of a is less than 1, then the graph will compress vertically, thus appearing wider than the parent function. For example, the function given as 3x squared will stretch the parent function x squared vertically by multiplying the y values with a factor of 3. Also, the function given as 1 over 3x squared will compress the parent function, which is x squared, vertically by multiplying y values with a factor of 1 over 3. Reflection. Reflection involves flipping the graph of the quadratic function over a line. When the coefficient of a is negative, the graph is reflected over the x-axis. For example, the function given as negative x squared flips the parent function x squared just below the x-axis. We can have a combination of more than one transformation. For example, the function of x given as negative 2 times x minus 3 squared plus 2 tells us to do the following. 1. Flip the function over the x-axis. 2. Vertically stretch the function by multiplying the y values by a factor of 2. 3. Shift the function horizontally to the right by 3 units. 4. Shift the function upwards by 2 units. The different type of quadratic transformation include vertical translation, horizontal translation, vertical stretch and compression, and reflection. And that wraps up our lesson on transforming quadratic functions. Here is a practice exercise. State the transformation process involved in the given function, which is -1/2 times x plus 4 squared plus 3. Feel free to drop your answer in the comments section. Smart Myths. Be the smartest.